Okay, eventually I come to this chapter. We have a statistical data design. Last week we already know something about index, and we also know why we want to do this thing called index. And we may need to ask someone. Previously we already, I think, Chinky already answered. And last week we also asked one more time. And this week we may continue to ask this question many times until everyone's familiar with this. So during exam, you should also remember what is what is the needed why. Okay, why we want to have an index. Okay, so. Today we'll continue this part. Actually, should be combined into one chapter, but don't know why. I think this one is good, so I do not need to say so much during one section. So this is a good point. Learning outcomes. At the end of this chapter, you should explain the different technique of placing a file record on this. For computing students, especially for you, when you already nearly finished the whole course, I think you should already well know this thing called file recording. Where you want to save your file. So last time we have a hard disk, and we also have this pen drive. My time have this zip disk, floppy disk. Yeah, I think more or less like this. But eventually, for nowadays, we have a cloud. You can save it to Google Drive. You can save it to, let's say, Dropbox. Yeah. Or you can even save into your computer. Not computer, handphone, it's a tab or iPad. Okay, so this one is where you place your file on this disk. So give another example of application: primary clustering and secondary clustering or index. So this one last week we already mentioned the difference between clustering and non-clustering. The difference between this non-dense index and a dense index should be sparse index and dense index. Another one is the use of dynamic multi-level. So what is the reason why this is important? Why we want to have a multi-level index? So if we have this multi-level index, and what's the example of using this multi-level index? So this is B3. Based on a few past year exam question, this B3 is actually quite popular. Okay. Explain the theory of hashing. So last week we already mentioned hashing. I think I won't go until the hashing part today, but the next week we will continue on this hashing. Use the hashing to facilitate this dynamic file extension. So we should know when the database is first start, the record won't be so much. But if you continue plotting data inside, the database will be expanded, and until one day, maybe your RAM won't be able to support this database, the execution of this database. So for our Oracle, we also have a little limitation. Don't forget, for our Oracle, since it's non-pay version, okay, this one XE21 is for us to learn. Okay, for someone that want to learn something, but it's not for daily database usage. So if you really want, then you need to pay and upgrade to a different version. So the one that we install is actually for us to go through and see whether the code is okay or not. So we have a basic understanding. Then the next time when we go to work, we will suggest to our boss, say, oh, last time I learned Oracle before, so you buy one Oracle, it's a database license, and we can just start. Okay, so this one is the idea of Oracle giving us using their special edition or Express edition, should be Express edition. We don't need to pay, but the RAM and the hard disk space is actually limited. So I think last time is I think not, if I'm not mistaken, it's only 2 gig plus the maximum hard disk, and the RAM that is allowed to execute is only 1 gig. So no matter your computer have a 16 gig of memory or 32 gig of memory, it only occupies 1 gig. And if the RAM is finished used, then it will hang there, and you may need to do something to eliminate all your data. Okay, so this one is for the Oracle. So the hashing part here and the B3 part here also have this kind of thinking. If the data continue to expand, it means your data storage will be expanded. So until a certain time period, your database management system won't be able to support. So this one will be a big problem. So that's why they try to do something to expand the index. So your memory is capable to support all this daily work. And so this one is next time when you really go to work, and you will face this problem, especially when you cannot bring down the whole database during this working hour, or even the whole day. It's not possible to bring down or to shut down the database or the computer. Okay, so this one you need to think, or you need to consider next time when you go to work. You also need to pay attention to this part. What kind of index you want to apply, or whether it will hurt the database working or not. Okay. So introduction to this part, the database is stored as a collection of files. So if you can I ask you to raise your hand if you learn a database? No. If you learn a database, no, not database. Sorry, I keep saying a database. I should say, if you learn a data structure and an algorithm before, can you raise your hand? Only 1, 2. All other things like Hongqiang. Okay, 4. I repeat again. Data structure and algorithm. Java. Okay, 1, 2, 3, 4, 5. Oh, continue. Hopefully, okay. So another half of this. So should be all now because you are in the one class, so you should know. But another. Okay, thank you. You can lower down your hand. Thank you. Okay. So based on my understanding is, if you go through some kind of this data structure algorithm, you should able to understand, let's say, how you're going to save your file and how you're going to access your file, whether through the binary search or any other searching method. And when the time I learn a data structure algorithm, the time is already Java. We know that this binary search is always the faster one, based on my understanding. But it will have some time circumstances that it will have this thing called worst case. So if the searching item or the search key is at the last one, means that the time will be a lot, okay, a lot. But how much is it? We don't know until we really apply it. Okay, so the collection of a file, it means if you have a lot, if your database is quite a lot, then like it will need to split the data into several files. Although what we see is one file, but it will actually split it into different what we call blocks. Then this is how database is actually saved. And we also need to know whether it's a 32-bit or 64-bit operating system. Every different kind of operating system, the way of saving the file is somehow different. And let's say for Windows and for Linux or for Mac, the file format is actually different. Okay, so you should know for Windows we have this FAT32, FAT16, and TFS. Okay, so this one is normally for Windows, but for Linux we have another one. We have exe. So the file format is different, and how it saves the file is also different. Okay, so the starting of the S is different. How it saves it is different. So the database is stored as a collection of files. When you install your database into that system, it will try to save it in that operating based on the operating system format. So the main issue addressed generally in a physical design here, we have this storage media. File organization, you mentioned later, many alternative access, each is appropriate in some situations. So you can see here, sometimes it is appropriate, but sometimes it is not. Okay, so this one is a problem. Then we continue to the index, and next one here is changing. So we know if we already save the record inside. So during our practical, we already for practical one, we already insert all the data inside the ADM space, table space. And we also try to search, do something. And eventually, until this few days, we try to do something called deleting, updating. Okay, so this one we already tried. And based on different way of accessing, deleting, updating the database, it may be suitable to use different kind of this index. So I think last week we mentioned if you insert the data into database and you seldom do any changes, you only keep insert and select. You seldom do any updating or deleting. Okay, so this is one kind of a format. Then it may be suitable to use some kind of algorithm or some kind of this index, maybe much more faster. Okay, so this one is the thing that you need to understand before you actually go through. And the maintaining of the file structure, and you should know for I think until only Windows 7, Windows have this thing called disk defragmentation. But start from Windows 8 until Windows 10 here, maybe Windows 9, it won't let you see the animation. So if you see this keyword, you can type defragmentation, and you can see this key this window. The keyword here is an optimized drive. So if you have a one hard disk, this is your one hard disk. Let's say for C. Okay, for C. When you optimize, it actually we allocate all your files bit by bit to a suitable location. So it may join all the files, join those that belong to one file together. I repeat everything. For this defragmentation, it will try to join those that belong to one file, the data together based on the sequential hard disk allocation. So for your database at this part, if you delete one record, it means that the space that this record is deleted is empty. For Windows, if this one is deleting, it won't. It actually just remove this part of. It actually just remove the table FAT32 for FAT32. It only delete the address of this location. So the space it won't save you more space. Okay, so it just mentioned that this one is empty. So next time, if any of the other file that I need only this space, it will just save it inside here. Okay, so for this part, if any changes, insert, update, delete of this record, then maybe we need the database management system need to do some kind of maintenance of this file structure. Maybe some of the record need to move in front here. Okay, so the rearrange of all the records may be needed after some time in order to speed up the searching or in order to save the hard disk space. Okay, so this one is for the maintenance. And after I do this kind of reallocation of the record, then updating of this index is required. So next time when you do the updating, then when you do the updating of the record, it should be much more faster when you do the indexing. Okay, so this one is the introduction of today's class. Hopefully you already understand this. Then you should be able to know what you should learn from this subject. Okay, so we have this thing called file organization. We have this indexing structure. This one is for this week. We'll go through this file organization one by one. Okay. Okay. The database is stored as a collection of files, as I already mentioned. Each file is a sequence of records. So if we save this into our hard disk, so this bit, if let's say the starting bit of this starting address of this file is here, then it will continue until the end. Sometimes, based on the different database management system, let's say I CBNS, it will try to may try to allocate another space for this table. Then if this record is at the end, then therefore maybe it won't reserve any other space for this table anymore. Then if next time when one record is inserted, then it will save the record 11, record 12 in another file. Okay, in another position. Although it is one file. Okay, although it should be belongs to one file. Okay. Generally, a separate file is used to store record after deletion. So if the next record is inserted, then actually the next space will be allocated. Record are either a fixed size or variable size. So you can see from here, if this part of a record here, when you create your table, you should let this database know this one is all number, let's say ID, and the ID is let's say six digits. Of course, the starting we won't have so many, so it should be start with 00001. So if we only have this number of ID, then the space allocate to this one may be a fixed size. Okay, so maximum is 99,999, and it is a fixed size. So if it is fixed size, means if when you didn't use it, means that you waste. But for the ID part, normally the starting is 00001. Then of course it whether you use it or not, the 0000 is still there. Okay, so this part is for number. For some of the variable, then of course we have a wacha2, wacha2, and others variable format. Based on different kind of DBNS, it may try to expand if the field size, if the record need more space for that field. So let's say for address, some of the address we set it 60 characters. So variable we set 60. If more than that, then some of the database management system will extend the size of that field, let's say to 128. Some will just let's say, okay, it's already maximum, you may need to cut your address, otherwise you won't be able to save to this record. Okay, so this one we have a fixed size and variable size. We also have some other variable record here. One or more field have a variable length. One or more field have repeating. One or more field are optional, and a file containing a record of a different type. Okay, so this one is all the variable length. We do not know how much of you. We do not really know how much we should assign to this length for the field. Sometimes it need more, sometimes it's less. So when I learned this database before, our lecturer tell us this. I think if I'm not mistaken, normally for our name, let's say my name, TANTAIRNG, only 10 characters. So if you assign me 20, then it means the other 10 is wasting, correct? But in this world, it is actually possible that the maximum length of our name is more than 10, is more than 50, or even more than 100. You can just Google and see the maximum character in this name in this world, or how much. I think we have one example is more than 10. Okay, so based on, of course, we won't wasting this space because only a few customer or only few member of this database need that kind of length to store their name. Okay, so this one is an example of a variable name. We have a few more things here. The repeating part. Some of the record, if it's repeating, we may have some technique just to point it to the same field, or we create one repeating part to point. So we do not need to save this field anymore. Okay, so this one is repeating. Some fields are actually optional. So whether you like to insert or not, it seems like not so important. So sometimes when you are registered to some website, it actually asks you your hobby. But I think nowadays, except checking your handphone, play around your handphone, what called surfing, it seems like not much hobby we have. Last time we still have a play badminton, swimming, climb mountain, or cycling. But now I think if I ask my little child what is your hobby, they will always mention watching YouTube or surfing. This one is their hobby. Okay, so for the field that is actually optional, it means the space is actually wasted as well. Okay, field container is a record of a different type, maybe movie, okay, music, picture, and some kind of a link. We actually do not know the actual length that we should assign to this type. So when you do some kind of this register, they ask you to take your own photo because you didn't come to the campus, but we still need to update your student ID. So they may ask you to take a selfie and upload your picture to the database system. At the back of this uploading your photo, they actually mentioned less than 1024 KB. To be one meg, take a selfie that is less than 1 meg and upload to database management system. So that kind of advice actually saves us a lot of this thing. So we have this variable length record, but we also can do some kind of suggestion to reduce the size of this record as well. So next time when you develop your own database management system, or when you have this user interface, you may always need to put a bracket, say, okay, this part. Okay, so let's say this one is a photo, your photo, and at the back here, in the dimension 1 meg. Okay, so this one is an example. Then if we apply this kind of technique, of course, the people will know, or we only can upload our photo and less than 1 meg. For your assignment and for your final exam, this time no more. I don't know. Who knows? For your final exam, if I'm not mistaken, when you upload your PDF, you also mentioned that this one need to be less than 10 meg. I think 10 meg is already maximum. If for the setting part is 100 meg, but I wouldn't believe your final exam the file will be 100 meg. Okay, so this one is the example. Okay, so continue for this. If we already know what is the length, it means we know sometimes we can control the size of our database. Sometimes we cannot. So if we can, then of course continue. It's how we save all this record to our let's say hard disk. So if we use a window, of course we can continue checking the file size. So if our ADM now is already, I think at the time when we said it is 200 meg, then maybe from time to time we just continue to check whether the size is already increased. Okay, so this one is for the file organization. So the method of arranging a file of a record on the external storage. So the keyword here is external, and it's not internal. So if internal means the hard disk. So for external, we will have this heap, sequential, and hash. So for this heap file, the one is unordered. So this one we already mentioned, record are placed on the list in no particular order. any other uh, saving activity before. It means all these files is actually split into different locations of the disk. Another one is a sequential file. We call our order by the value of a specified field. So let's say you have one example here. Okay, so you can see of this sequential file, the number is in sequence. If later when you want to save something inside, or then it need to do some kind of a rearrangement. So if for this one, you can see it is not in sequence. 217101. Okay, so it is not in sequence. Then this time, we did say next time it may be another part. So this one it will be a different block. Okay, so although it should belong to one file, but it's already in a different location. So in some computer system, we say this one belongs to different block of record. Okay, another one here we have this hash file. So the record are placed on the disk according to the hash function. So this is the hash algorithm. This is the space allocated to storage. And if you want to find something, we just use the key, use this algorithm, and we can find the place easily. So this part we already mentioned last week, and we have some more example that can help us to more understanding about this hashing. Okay, so just now we have this hashing algorithm, but actually this hashing algorithm last week we already show you some Java example. We have the country, we have the main city, let's say UK, London. Okay, so this one is one example of this hash algorithm. We also have another kind of algorithm here. We use this percentage. So let's say we have this space that allocate to this storage is only 8. We have 8 slots here. So if you want to take something inside of this table or the power allocation, so if something that you want to save, since we have a number here, 36, modulus by 8, divide by 8, modulus by 8, and then get this number, the remainder. So it will just stick into this location. So if it is more than one record need to be saved here, then it may just need another way of what we call multi-level hashing. Okay, so we finished the first part, intro, and we continue to this part. Index. Index is always a big topic in this database management system. Last week we already mentioned if only one more company, so let's say my record, until now my record for this database is nearly 30,000, the member of one organization, and of course have a lot of different activities. 30,000, it seems like a lot, but when we search, let's say the name of this member or the ID of the member, you not even need 1 millisecond. So when you press enter, the record actually show immediately. So this kind of searching actually not really need this thing called index. But if in the real, not in the real, but in the business or commercial world, the record will be continue or plug in. Not only at 30,000, but maybe one day is 30,000. My experience until now is the whole maybe 20 to 30 years of this membership is nearly 30,000. But for the commercial, let's say Lazada or Shopee, the daily transaction maybe already more than 10,000 or 20,000 daily record. So if they need to keep this record and refer back in the future, so it means the database will be expand a lot. And if you log in to Lazada or Shopee, and you want to find back your purchase record history, it seems like once you click, it just show. It seems like it won't let you take so long to display all your own records. Okay, but searching from the millions or billions of records, you get your purchase history. It seems like during this 1 to 2 minutes, not 1 to 2 seconds, it is really fast. Okay, so how we're going to do it is through use of this index. So next time when if you already purchase or order from Lazada or Shopee for a long time, you can try and see. You want to search back your purchase record or history, see how long you take. Okay, so this is the use of using an index. So from a millions or billions of records, you can get your own purchase record in 1 to 2 seconds. Okay, so we will go through. Last week we already go through B3 hash and bitmap, and we didn't see a joint index before, but means the joint. Okay, we will mention this later. So we will go through all this, and before we go through, you just pay attention to this part. So this one, students need to pay attention to this part. The index here mentioned say for B3 is actually common type of index used in a database. I say the starting of this class I already mentioned for searching. I think B binary search is already very fast. And this part is for B3 index. This one is the most common type of index in the database. Okay, so you can see how important this B3 is actually work in the database. We also have this hash index. This one is good for simple and fast lookup table. Okay, so you can see from here, say good, not common. It means sometimes it is not really sometimes it's not really good in some circumstances. So that's why it says only good. And you, after today's class, you may need to go through again and again based on the different kinds of a database, which kind of an index is actually better. Okay, so this one is prepared for your final exam. And last week we already mentioned for this bitmap, it seems like if you want to make some kind of a multi-column indexing, then maybe a bitmap will be better. Okay, so the last one is joining of all others. Okay, so we go through this. Okay, so this time we already mentioned how we're going to store, how this individual record is actually stored into this. And because the different way of a store to the disk. So let's say we have a skip sequential. We know that the instruction accessing time when we insert the record into the database, it is based on that time this hard disk space. So if currently the hard disk can find some space that let you save it, then give it a simplicity. Okay, so this one is for Windows system. This one based on my understanding, the faster way to save to the disk, if the computer system can find that space for you to save it, then they will save it. So for the accessing time, since the record is already saved inside, if you want to search that record, it means that the computer system will need to jump from one place to another in order to get that record. Okay, so students, pay attention to this part. The assumption here is that accessing the hard disk, and this hard disk is the hard disk that we mentioned previously, the HDD hard disk. Of course, for our SSD or for our RAM or even the newest technology, the time that need to use will be much more shorter, but actually it still needs some time, right? Okay, it still needs some time. So the access time for this equality search from the top until the end, the record with a specific value in an attribute. So the equal sign is actually used. So let's say I want to search the name is equal to Tan Thailing. So this is the searching key, and it will search the record from the top of the beginning of the data table until the end. And see whether I have this name or not. Okay, so this is equal sign, equality search. So how long it takes to search this item or search key. The second one is the range search. My weight is around 70 to 80. So if I want to search those weight that is between let's say 70 to 80, then this one is what we call range search. Or we have another example, the age 30 to 40 years old. This one is what we call range search from a certain starting value until the end value. So between this value is all accepted. So this one is what we call range search. So assessing of time for this equality search and this range search is actually different. Okay, not only a comparison equal or less than or more than, it actually takes a little bit longer time for the range search. Okay, so we have a comparison more than this number and less than this number. It means it needs to take two comparisons. So this is the assessing time. We have another one called insertion time. Okay, so this is insertion time, the time to find the correct place and insert the new data. So this one is insert. Don't forget that this part when we do this one is normally what we do. We find the place and insert the new data. So for normal data structure algorithm, this is the way that we do. But for database and management system, we have another one here, update the index structure. If we already apply the index to that database, to the table, then we also need the DNS also need to update the index structure as well. Every time when there is one insert, every transaction, it will need to do this updating. Okay, so continue, we have this deleting, same thing, find the item, then I try to delete it, then I'll update again. So for this insert delete, we actually have this thing called overhead. And then we also have another one called space overhead as well. This space overhead is actually the space to store the index structure. So previously we only need to save the record, but now we also need another index, and this index is actually the data, then the pointer to the specific location. So this one is actually the space overhead. So previously, last week already mentioned this one. If we not really need it, then we try not to use it. But if we have a million, later we mentioned this. If we have a more record for this, then only apply this indexing will be reasonable. Okay, so it's not really a must, but reasonable. Okay. Right, then we wrap up 5 minutes before we go to the plus one here, then we come back by 10 past 4. Okay, let's continue. Okay, so just now we already mentioned different kinds of this index. Then I'll continue. I will also mention if I want to evaluate this index whether the speed will be fast or slow, then I'll be trying to use this access time, insertion time, deletion time, and we also need to mention about the space overhead. Okay, so for the first three, the accessing until the deletion time, it actually it is related to the data structure algorithm. The last one here, the space overhead is actually for the storage. So if the speed is very fast, but eventually if the space that needs to keep track of all these index is too high or too much, then it is a drawback to the database to the system as well. Okay, not only the database management system, but also to the computer system as well. Okay, so last week we mentioned different kinds of this index. Then I'll continue. We talk more deeper about this different kind of this index. So we have this classification of indexes. So clustering versus non-clustering. So it means the if we have a one table and this table is actually sorted based on the based on the ID. Okay, so let's say now I'm the first one insert into the database the table, and I have get the ID of 001. Okay, so continue with 002, then continue. So the minimum at least we have a three number. Then continue. If more than that, then it will continue to increase. So this one is some setting, and if we index based on this ID, the primary key, it is unique and it won't be duplicated. So it is what we call clustering. Okay, so only one index for the table, so only one clustering for the table. So if you put index for using this primary key, then we only this only have a one clustering index for the table. If you want to have a more index, then it is considered as non-clustering. So we have an example here. It's next page, sorry. Okay, so this one we will mention later during the next few slides. We also mentioned about this dense and space. So just now we already mentioned about this space overhead. So when we think about this space overhead, some of the algorithm, some of the programmer or the one who developed this algorithm, they need to think about some way to save this space to minimize the impact of this space overhead. So they come up with this dense versus fast index. So the meaning of this dense index is every value of the search key attribute it will be found in the table and also appear in the index. It means if we have a 10101 here in the bucket, then no, it should be say if we have a this ID in the table, then it will appear in the bucket or the hash table. Okay, so every of this record in the table will have another key in the hash table. So this is what we call dense index. And index record appear for every such key. So every of this ID will be appear in the hash table. So this one is the dense index. Whereas for the sparse index, it means some of the index is not actually need to be repeated. So we have an example here. This one, biology point to this part. And the continue of this, let's say this one is the subject. So for the computer science, this part is repeated. So it not need to continue on this part few times of this computer science here. So this is considered what we call the sparse index. Okay, so you only point to this part one time, then the searching will be from the top to the bottom. So this one it saves a lot of this space. We have another example here. Content index record for only some search key value. You can see from here, we have this number 10101 and it point directly to the record. Then it jump to 32343. So this whole record is actually missing. So why is missing? Because we do not really need to have so many. Some of the programmer or some of these some of these programmer who develop this algorithm or thinking of creating this algorithm actually mentioned the searching of this database or searching of this record is actually not that difficult if it is sorted. So if we find this number, then we can continue searching for the rest. That will not be too hard. And if we want to cut short a bit, what we can do is we cut short this table into 3 parts or even 4 parts. Then if the number that we search is greater than this one, then we can jump to the second one. If it is still greater than this, then we can jump to the third one. So based on this kind of algorithm, based on this kind of thinking, we create one algorithm that is what we call faster index. We can jump to one index location that is much more near to the search key. Okay, so at the same time, we save a lot of this space and minimize the compact of this space overhead. Okay, so this is the idea one want to use this sparse index. Okay, so this one is the first example of a sparse index. Second one, and to locate a record with the search key, we find the index record with the largest search key that is less than 10k. Then continue search the sequential starting the record to which the index record is. So we find this one, then continue search to the rest. So this will be much more faster. Okay, so this one is the idea why we want to use this sparse index. Okay, again, do some comparison to this sparse index. So student, I think you need to spend some time just to understand this comparison. Because during the final, they always have this kind of question compare and contrast. What is the difference between this dense index and the sparse index? Of course, it may ask you to compare all others, but you need to understand say we have a 10 record, let's say we have a 10 record here, it means that we have a 10 hash table, the record, we need to have a 10. But for this one, if we also have a 10 record here, then we only need 3. So it saves a lot, more than 70%. Okay. So that is the reason why we want to use this fast index. Just now we already mentioned the searching. If we already find the key very near to the one that we have, then it actually needs the time that need to search the key is quite short. Okay, less space. Then another one is less maintenance or overhead. So if if you insert the record someplace here, or you remove the record someplace here, you do not need to redo all this. Let's say the one that we have. Okay, so just now let's say this is the key that let's say this is the key that we search 76543. Okay, and now we want to remove this record. We search from here 32343. Oh, it's better than. And then if you can search, you can understand this part. Find the index record with the largest search key value less than 10k. And it may search this one. Okay, this one is already a better than, so we can find back to the previous one. So searching from here down. And after we search, get the key. Okay, after we get the key, and then we try to remove it. When we remove or delete this record, we actually do not need to do the updating to this part. Okay, so we can see from here, if for the previous one, if we do any of the changes, it means that we also need to do changes here. So this one is the maintenance cost. So it is the maintenance overhead. So previously we have this space overhead, and now we have this thing called maintenance overhead. Okay, so the maintenance overhead is not only for deleting, but also for insertion as well. We insert something inside, then we need to update the table as well. Okay, because that's the index. When a file is actually modified, every of the index on the file must be updated every time. Okay, so one insert, one update, one delete, one update. So updating the index imposes this overhead on the table database modification. So generally, the slower than this dense index for locating the record. Of course, we have a disadvantage, and the disadvantage is the part. So it's a little bit slow. So this time we already mentioned, if the key is not too much, then we find, if the record is not too much, we already find this number, then we can just we already find this number, we can just continue to find some here, and the time that take to find the record is not so much, but it's still slower than the dense index. Okay, so it still need to find few more records until we get the number. So that is why it says it is slower than the dense index. The searching is faster for the dense index, but after you find, if you need to do some kind of this delete or updating, then for this sparse index, it may be much more faster because it may not need to update this hash table. Okay, so this one is the comparison between the sparse index and the dense index. The last point here, we always this one is theory or comparison. You get one, you may lose another one. So the sparse index, it needs less space and it needs less maintenance, but it is a little bit slower. So this one is the characteristic of this sparse. So compare over these two, you need to judge which one you want to use. So for good track of sparse index with an index entry for every block in the file, corresponding to least search key value in the block. Okay, so for the file, we continue to mention this with the index entry. We have a search key K, and actually have a one hash table. We point to this part, and this hash table only mentions about the first item of this block, and do a comparison. Okay, do a comparison. If this number is less than, then only a search for this part. Continue from here. And so this one is the pictures, but eventually this one is not really the one that we need to use is actually sorted. So this one is just one example because only this part we have this block. We also have another example here, but it seems like not very clear. So the data block 0, just now we already mentioned, then we take something inside here. Until some time, the file may be end, and another one is start, and it is in another location. So that's why we call it block 0, block 1. And the hash table here actually only needs to point to the starting of this data block, and it can save a lot of time. Okay, save a lot of this hash table, the maintenance overhead, and the space overhead as well. So of course, doing this means how many records inside of this block, then you need to search from the top until the end. Okay, so good trade-off. The good part is hash table is less, maintenance is less, the space overhead is less, and it is a little bit slow because you need to search from the top until the end inside of this block. Okay, so this one is the comparison between the dense index and the sparse index. Okay, so just as I mentioned, we have this clustering index and a non-clustering index. Okay, so this one is this one is 2021, year 2021 May final exam. The example of this is one example. So for clustering index, we are ordering this index match ordering of a value of a search key attribute in the file. We have a one. Okay, so previously we mentioned for clustering index, normally it will be applied or when the primary key is the key that is indexed, then this is considered as clustering index. So compared to the clustering index, we have a non-clustering index, and this one we try to apply index to a table and the field that is actually not indexed. So if we want to find something, let's say this one is the salary or whatever. Okay, so if we want to find something here and this is not indexed, we consider this one is non-clustering index. And what this can be do is we want to refer to this 65,000. Okay. So we want to refer to this as 65,000, but since it is not indexed, so what we try to do is we try to have a one table, hash table that is indexed from the top until the end, and we have a one bucket, and this bucket is actually pointing to the actual location. Okay. So previously we mentioned for clustering index is normally is indexed based on the primary key. So the key, the field is actually sorted. No, that won't create any problem. But for this kind of index, you can see the number is actually from top to bottom is not sorted. It's very messy. So we need to create one table that is actually pointing to different buckets and pointing to different locations. So the update of this is actually the maintenance overhead is actually quite a lot. So only when it is needed to index this part and searching for this, and only we create the index for this. Okay. So example one here is the instructor relations store the sequential by ID. Find all the instructor in the particular department. Previously, we already have mentioned here, have an example. Some of this can be sorted, some is not. If it is not sorted, then when we try to point, it means this ID or this hash, the maintenance is quite a lot. Second example here is find all the instructor with a special, okay, so we know this one is salary. So specify a salary or with a salary that in a specific range of a value. So question here, so specific value, when I say when I say the salary is 72,000, what is this mean? When I say the salary is between 70 to 80,000, what is this mean? Vinci, Wang Vinci. Finally, I have some time to write. Vinci, we have one different here. If I want to search 72,000, this one is one kind of a searching. We also have another kind of a searching. It's between this range. I want to know the name of this searching. We just mentioned before, maybe you can recall. This one is exactly the number 72,000. This one is between this range. Any more? Another one? No. The first one is correct. If you can get the first one, you should know the second one. Okay. Okay, so if we have exactly the key that you want to search, let's say computer science, 72,000, then this one is what we call equality search. If we want to search the whole range, so let's say from 70,000 to 80,000, this one is what we call range search. So you can see from here, for this non-clustering index, if we want to find something that is not indexed, not in a sorted order, then when we build one this non-clustering index, it means we need to build a full bucket for this part. So previously we mentioned this dense index and sparse index. If we have this non-clustering index that point to or apply an index to the field that is not sorted, so this kind of index will be dense, always dense index, because the bucket of this part is actually a point to different of this field, because it is all not sorted. So we have a 10,000 of a record here, means that we have a 10,000 of a different bucket here in order to point to specific location much more faster. Okay, so you can see some more example here. Another clustering index must have an index record for AB search key. Okay, we have the bucket here, how many records, and then we have how many buckets. The index record point to the bucket that contains pointer to all the actual records. Okay, so for 4,000, 40,000, point to this part, then point to this part, that is 40,000. Okay, so this one is the example, and also the differences between the dense and sparse index. Okay, the bucket structure is used if a search key is not primary. So the search key that we want here, because it is not primary, but only this one is primary, and all this is not sorted, is not primary. So we apply this bucket structure, and this one is an example of a dense index. Okay, clustering index can be fast, since it's always possible to find record with intermediate search key. Okay, so we can continue here. Clustering apply to this in ID. So this ID is actually sorted primary key. So we can use okay, we can use this fast. Yeah. So the first one you point to 10101. The second one here is already jumped up to the center, nearly to the center, 2343. So if we find this record here, then continue searching the rest will be faster. At the same time, the hash table won't be too large. Okay, so compared to the non-clustering index, this dense index should be used. Okay, so this one is the comparison. So let's say during an exam, ask you why we want to use fast index or why we want to use this dense index in clustering or non-clustering indexing. So this one is the reason. Which one you should use? Okay. Okay, so because of this, you mentioned say sequential search. This sequential search means from the top until end, we search one by one. For this clustering index is efficient because we know, let's say we want to search this record 3, 3, 4, 5, 6. From the top until end, not even end, we already get the record. Then we can just directly apply to the record easily, so there won't be any problem. So the searching for this part should be very fast and it's very efficient. But searching for sequential search for this non-clustering is very expensive. So if I want to find something, let's say 40,000 here, I think this one is missing 40,000 here. Then maybe we this one is the best, what we call the best case. Only the few record and we already apply the 40,000. So this one is the best case. If I continue searching from the top until the end, 80,000 or this part, then it comes the worst case. So for the field that is not sorted, we won't sure that whether the record is actually there or not. So we may need to search from the top until the end, even we already get the record. Okay, so this one is some drawback if with or without this indexing. So for non-clustering index, if we didn't have this part, for non-sorted field, if we didn't have this part, the searching for the salary will be a big problem. Okay, so you may need to search from the top until the end. So that is the reason why this non-clustering index, when applied to the salary part, is needed to have a lot of this dense indexing. Okay, we continue to mention about this. Each record access and fetch a new block from the disk. So this time we already mentioned if we have a one hard disk, and the record for the first three block, this is three records maybe in one block, and the second three records maybe in another block. So if we have this kind of a problem, means that the file storage system, if we have this kind of a file storage, then the searching for this record it may take even a longer time. Okay, so this one is some drawback. If we didn't have this indexing, then it may take even a longer time. Okay, then continue, we have this thing called multi-level index. This one is an example. So if we have one file that have a 10,000, no, 100,000 record and 10 record in one block. So if we have this fast index here, one index record per block. So how many record will be the index? Of course, the example is already, the answer is already there. So we have 100,000 divided by 10. 100,000 divided by 10. So we have this number 10,000 of this index record. So the hash table or the bucket will need to keep track of this 10,000 index record. Okay, so this one is the example. And the index will require 10,000. Yes, 10,000 divided by 10 is 100 blocks. So it actually point to only 100 blocks. Okay, so this one is the image that you need to understand first. Then only we continue to mention about this multi-level index. Okay, we know if the record is a lot, and so this one is at the table. We have a lot of this record. Let's say we have 100,000 here, and we have a one dense index, and this is because we divide by 1, we divide by 1 divided by 10. So the index for this one is 10,000. So this one is 10,000. Oh, we should have one example. This one is a 10,000 bucket to let this index pointing to the actual row record. So it should be point to this type. Jumping because it should be fast. Sorry. Okay, so if we have this, it means we can save a lot. But the problem here, if an index does not fit into memory, then access become expensive. Okay, so previously we mentioned if the Oracle database system that we use, the Express edition, we only are limited to 1 gig RAM memory can use to run this database. If your index, the table is already more than it use more memory to changing from time to time. Okay, so this one is very expensive. So we have one question here. Student, do you know the difference between SSD and HDD hard disk? If you know, then I'm trying to do the comparison of the speed that need to save one file, let's say 1 gig movie to SSD and 1 gig movie to HDD. I'm trying to check how long it takes, okay, and how long it takes to get the disk file to a pen drive. Of course, the pen drive should be the same one. So the speed to access the disk will be much more faster. The speed to access the disk HDD is much more lower. At the same time, if your computer system is still using a HDD, it means when you do this saving reading of a file, it actually take a lot of time. So if you experience before, if you still are using a little HDD, when you try to do a window update, eventually your computer will like hanging for a longer time, and a lot of time it's actually doing the hard disk read write access until it will not let you do any other stuff. Okay, so this is accessing will become very expensive when it cannot fit into the memory. It will just try to write all the thing in the memory to hard disk to clear, but actually it just move it there, then later continue move out something to do the processing. So to reduce the number of disk access to the index record, what we're trying to do is we try to do another two things here called outer index and inner index. So as far as index on the main index itself. So by using these two things, we minimize, try to make a little memory, the usage of this memory a little bit smaller. So we try to access this one first, then we get the number already, then we clear it, we use another one, and check back to the table. Okay, so if the index is too much until your memory won't be able to hold it, then we can continue using this outer, inner, or even if even these two is not even able to hold your table, then we can eventually more level to hold it. So if even outer index is too large to fit in main memory, we have another level of index can be created, and so on. Continue until we'll be able to minimize it until we can fit it to the memory. So the last part here, we have this index at the O level must be updated and insert or deletion from the file. So if the database is too large, then eventually we need to do this. But we also have this burden or overhead here. Update of one record, it means we need to update a lot of this outer inner index as well until everything is updated. Okay, so this one is the intro of this multi-level and example. So this one is the hash. How many level we have? We actually not really care, but we just have the idea. We have this multi-level of this index. So if this one is too much, then we can create few more here. Okay, so we end here today, and we continue to mention this B3 index next week. This one is a big topic, and it seems like a lot of these different years of past year exam is setting to have this B3 index. So we will pay more attention to this next week. Okay, so before we go, any questions? And for last week practical, anyone already sent me the work? Yes, no? I only received a trinket to the email. Anyone already submit to Google Class? Okay, let me already send this email. Which email? Practical 5 or get me? I didn't receive the one on my personal or even the data email. Others, anyone already sent me? If no, then I won't be able to update and share with all others. No? Okay, then that's all. Okay, so we end here, and see you again this Thursday. Bye-bye. Okay. Everyone have a lot of things to do. Okay, then. Yentong, is your problem solved? The insert order detail? No. Sorry, but I did not know how to help. Yeah. If you send your insert order detail to others, ask them to try, see whether a problem. If their one didn't have any problem, means your database creating maybe the size of a database, the ADM is too small. I'm afraid it's already full. Then won't let you do the insertion. Yes, I just guess. I didn't see the actual storage. So this is just suggestion. Okay, fine. Thank you. See you again. Bye bye.